the graphs of sine and cosine trigonometric functions. And we're going to take a look at this graph that I caught online. And I'd like you to take a look at the red curve. If you take a look at the red curve that goes along here, that is the sine curve. And there's a couple things that, of course, that I'd like to notice about it. And I'm actually going to draw a little picture down here at the bottom of the screen regarding sine. All right, so here's the sine function. We're just going to talk about the basics in this particular video. And what I'd like to do is to just first describe what the sine curve looks like by redrawing it down here. Okay, so we're going to look at one period of the curve. In other words, one full pattern. You'll notice that the curve starts at 0, right? It starts right here at 0, and it goes all the way up, goes way and then down. This is one complete pattern. It repeats itself infinitely left and right, but that's what it looks like. It gets to a maximum height of 1 and a minimum height right over here at -1. So it's kind of has an interesting look. So when you just look at the curve, which I'm going to do, well, let's see if red is going to cooperate today. But red will have that kind of look like this. Trying to recreate it. Didn't do such a bad job there. And that's what it looks like. So what do the numbers look like? Well, the numbers along the x-axis, if we were to take a look at them in degrees, would be 0 right here at the origin. Just looking at the x values. Midway through the curve, if I had drawn this perfectly, the first hill would be this exact same shape as the bottom valley, except I have them a little bit skewed, but not too bad. And it goes all the way over here. It ends at 360 degrees. Yep, I realize over here in the graph it says 2 pi, but 2 pi is the same as 360 if you know your degrees and radians. So halfway through would be 180 degrees. Of course, in the graph it says pi. Pi is 180 degrees. All right, so we have that shape. Now, one thing you need to know about these sines and cosine curves is that you can break them up into quartiles. So half of 360 is the middle, 180. Half of 180 is 90, which actually matches to the top. In other words, the maximum point right here, this max value, the highest point on the curve. Then here, right between 180 and 360 is 270. Okay, and that would be the lowest point right there on the graph. So the highest point it gets up to is 1. The lowest point it gets down to is -1. So we say this curve is an amplitude of 1 because it gets as high as 1 and as low as -1. So 1 unit away from the x-axis is as big as it gets. So this would be the equation for sine. Y equals sine of x. Okay, so just a few things you have to look at. So the period, again, is the length of one pattern. So you can see it goes from 0 to 360. We would say that it has a period of 360 degrees, but the amplitude is 1. All right, let's now take a look at not the sine curve anymore, and that is an E for sine. But now let's take a look at the cosine curve. Cosine. All right, so I'm going to draw a similar looking picture over here on the right side. Now, of course, it's just being hand drawn, so it's going to look a little, raw, not as clean as it does in this graph up here. But you can see that the blue curve is the curve, and I'm going to be a little smarter this time. I'm actually going to draw the quartiles ahead of time. Okay, it actually makes it easier to graph, and it still has the same amplitude. It gets up to 1. It gets down to -1. Okay, that's right. If you look at the blue curve, it gets as high as 1. It gets as low as -1 over there. So that is its amplitude as well. But notice that the cosine curve doesn't start at the origin like the sine curve does. So cosine starts here at 1. It starts right at the amplitude. And then what happens is it hits the x-axis. Then it goes down to its minimum point halfway through this period. Then it goes back to the x-axis, and then it ends up here. Okay? Ends up at the amplitude. Now I'm going to put this in blue because I'd like it to match the white graph that we have up there. And it definitely will have this wavy shape. It looks like that. And that's what the blue curve looks like. Alright, and again, it has the similar values as it did with sine. It's 0, it's 360. Halfway through, let's see, half of 360 would be 180. Half of 180 would be 90. And actually, if you add 90 and 180, you'll get the 270 right over here, which is this point right over there. Yep, I realize here on this graph it has 3/2 pi for 270, but it is 3/2 pi is 270, and 1/2 pi is equal to 90. So we are matching the radians and the degrees between the two curves. Alright, so we learned a few terms. Period is the length of one repeating pattern, and then we learned amplitude. That's how far it is displaced, the maximum distance away from the x-axis that the curve gets. Sometimes physicists call that a displacement number. Sometimes we say, what is the distance from the high to the low, and divide that distance by 2. So from 1 to -1 has a value of 2, but you divide that by 2, so you would say 2 divided by 2 is 1. We say it has an amplitude of 1. Same thing over here. It gets a high value of 1, but then a low value of -1, so that distance is 2, but you divide it in half, and you get 1. It has an amplitude of 1. Alright, so this curve is cosine, and it does have this cosine of x is the actually equation of that curve. Alright, so we just talked about a few basics, a little connection between radians and degrees, and we saw that these curves can be broken up into quartiles, fourths.